How's it going, everyone? In this video, we're going to look at the 8 teams that made it to the quarterfinals in the World Cup, and we're going to see if there's a statistically significant difference in their performance in the tournament so far. And to measure their performance, we're going to look at the goal differential, and we're going to check for that, whether there's that difference, statistically significant difference. We're going to check for that using the ANOVA test, or analysis of variance test, or ANOVA test for short. So I'm going to show you how to run that test in Excel, what the numbers in that test mean, and we'll see the results, right? So we'll see the conclusion. Is there a statistically significant difference between these teams' performance or not? Now, by the quarterfinals, you'd expect that there should not be a statistically significant difference, okay? Because the first 3 games that each team plays, so here for each team that made it to the quarterfinals, we have 4 data points, okay? And this is the goal differential from each game that they played, okay? So for example, the first game that Netherlands played, the number of goals they scored minus the number of goals scored on them was 2. Okay, so they won by 2. Argentina, their first game, they lost by 1. Number of goals they scored minus how much was scored on them is -1, right? 0 means a tie, right? Croatia's second game, they won by 3 goals, and so on. Okay, so the first 3 games that a team plays, this is in their group of 4. Okay, the teams are arranged in groups of 4, and each team plays everyone else in their group once, right? So that's 3 games. And if they win, they get 3 points. If they tie, they get 1 point. So after those 3 games, in each group, you have the winner of the group, whoever scored the most points. Okay, not goals, but points, right? Because a win in a game gets you 3 points. A tie gets you 1 point. So you have the winner of each group who scored, who got the most points. And then you have the runner-up of each group who got the second most points. And those are the 2 that make it to the round of 16. So in the round of 16, which is the 4th game that everyone plays, in the round of 16, you expect that half the teams will have performed better than the other half of the teams, because half of the teams are winners of their group and the other half of the runners-up of their group. But after the round of 16, right, theoretically, the better team wins, right? So after the round of 16, half the teams fell out. The 8 teams that go on are theoretically the better teams, so by the quarterfinals, when you just have 8 teams left, you should expect that their performance is equal. Okay, that in terms of statistical significance, there's no significant difference between their performance. That's what you would expect. And so the 4th game that each team played here, that's their round of 16 game. So now there's 2 cells highlighted here, okay, because these games went to shootouts, right? So after regular time and after extra time, you have shootouts in soccer. That's how soccer works. So if the game is still tied after extra time, they go to shootouts, and whoever scores more goals in shootouts wins. Okay, so here there's a 0 because the score was tied before shootouts. And the tiebreaker, right, brought Croatia ahead in their game, brought Morocco ahead in their game, and there's no shootouts in the group stage. Okay, so to make this comparison more fair, we're placing a 0 here as well. Okay, now later on we'll show what the results will be if this was not a 0, but just to begin with, we'll have 0s here as well, right? So the game was tied before shootouts. So how you do the ANOVA test. Okay, you go to data and you click data analysis right here. And there's different kinds of things you can do. And the very top one, ANOVA single factor, click OK. And then you have to select some things, right? So here for input range, you click this arrow and select the data, right? The table that you want to run the test on. Then click that arrow back down. And then we have group by column, right? So each column is a different group. And what the ANOVA test does is it shows you, well, what's the probability of seeing the difference between the groups that you see, assuming that the groups are actually the same statistically. Okay, so if the groups are the same statistically, you could still have some statistical variation, so there is still going to be some difference. If you run this say random process of seeing how each group scores. So what's the probability of seeing the difference that we observe, assuming that on average all these groups perform the same? Okay, so then we have this check mark here, label in first row, because the first row is not the data, it's just the label of the group, or the team in our case. This alpha value, I'm going to explain what that means later on. We're just going to remember that it's 0.05, and I'm going to write that down. Okay, so don't worry about the other stuff written here. I'll talk about that later. Alpha is 0.05. So then we have our output range where we click on that arrow and you just click where you want the results of the test to appear. Click on the down arrow. Now we can click OK. And we have a bunch of numbers come up. Okay, so we have the names of our groups. We have the count, which is number of data points, or in our case, number of games played per group. We have the average goal differential for every one of those teams. The number we want to pay attention to right here, this is the p-value. Okay, and that's that probability of observing the difference that we observe, assuming that on average each of these groups performs identically. Okay, and the p-value we see is 0.818, or in percentage 81.8%, approximately 82%, which is a pretty high percentage, right? 82%, that's a high percentage, right? So assuming that on average each team performs the same, the probability of observing the differences that we observe between these teams is very high, 82%, which tells you that it's a reasonable assumption. It's a reasonable assumption that on average these teams perform the same. Okay? Now, you might be looking at this and thinking, no way, no, I know these teams, they don't perform the same. Just because an assumption is reasonable doesn't mean that it's correct. But it's still reasonable, right? So that's what the data shows, that the differences between these groups is similar enough that if these groups are identical on average in their performance, the chances of observing what we're observing is quite high, 82%, which tells us that, yeah, it looks like in the quarterfinals, the teams that made it through are quite similar. Okay. Now, this 0 here, okay, in the case where we had shootouts in the round of 16. So it could be debated. Should that be counted as 0? Should that be something else, right? So you could say, well, shootouts are like a tiebreaker, right? So whoever won the shootout really should get 1 point, right? Like another goal, as if they scored another goal, right? And that's what we have here, okay? So here, instead of zeros, it's a 1, right? So the team that won the shootout, we're counting their goal differential as 1. And here's what happens when we run the ANOVA test in that case. Okay, so I'm going to highlight the table, okay, columns, labels in first row, alpha value the same, output range right on this sheet, click OK, and if we look at the p-value, it's actually higher. It's now 88.6%, right? So if we count a shootout victory as an extra goal, well then these teams are even more similar, okay? Then the probability of observing the differences that we're observing is even higher, assuming that the teams actually perform identically. Now, why is that higher? Because that extra 1 in goal differential for Croatia and Morocco actually brings their average goal differential up, right? So on average, it's 1 for Morocco. For Croatia, it becomes on average 1. Whereas before, when we had zeros here, Croatia's and Morocco's average goal differential was 0.75. It was lower. It's actually the two lower values. And it was farther. It made them more different from the rest of the groups. Making that goal differential higher by 1 makes Croatia and Morocco catch up to the rest of the groups a bit more, which makes the rest of the which makes them more similar to the rest of the groups, right? So if the groups are even less different, even more similar, well then you're even more likely to see this kind of result, assuming that on average the groups are the same. Now, what if we count the goal differential as the actual difference in goals scored as a result of those shootouts? And that's what we have here. Okay, so Croatia won its shootout by 2 goals. Morocco won it by 3 goals. And if we run the ANOVA test here, okay, I'm just going through the same process, right? Columns, labels, alpha 0.05, output range, same range. Okay, then it becomes 0.94. Okay, 94%, even higher. Because again, with an even higher goal differential, 2 and 3 versus 1 or versus 0, right? Well, now on average, their goal differential is even higher. Well, now they've caught up to Brazil, right? They've caught up to, so Croatia's caught up to Brazil, to France, right? Morocco's even higher, right? They've caught up to the Netherlands, right? So that higher goal differential for Croatia and Morocco catches them up even more so to the rest of the teams, makes them even more similar to the rest of the teams. So these results are even more likely, assuming that on average the teams would perform the same if the tournament was repeated again and again and again. So we have a p-value of 0.94 or 94%. So whichever way you count goal differentials for shootouts, you still end up with the same result, that we're very, very likely to observe these differences, assuming that on average these teams would perform the same as each other if the tournament were repeated again and again and again, which is a good sign, right? That's what the quarterfinals should be. The teams should be roughly equal, which means you're going to have good games and all that. Okay. Now, we mentioned that alpha value, and I want to talk about how the F-test actually works. So we have these two other values around the p-value. Okay, we have the F and we have what's called the critical value. And where it's just F, that's called the test static. So this is a measure of how different the different groups are. That's what that F value or that test static is. And how it's calculated, okay, this is the equation for it. Now, if you're not familiar with reading math, don't worry, I'll explain it. Math, it's just a hieroglyphic language. So what we're doing here, we have something on top and we're dividing it by something on bottom, right? This line here is dividing. So what we have on top is the average of each group minus the average of all of the data, all of the goal differentials for every game played by every team, that total average. We're subtracting it from the average of a group. We're squaring that difference. Okay, so whether the difference is positive, negative, it gets squared, the result is positive. Multiply it by the number of data points per group and add that up for every single group. Okay, so if we go to this tab here, we're actually doing that. We have the average goal differential for each group. We have the total average goal differential for all the games played by all 8 of these teams. And we're subtracting one from the other, squaring the result, and multiplying by the number of data points, the number per group. The number of data points is 4 per group. So we have all these differences. We're adding them up, right? That's what we're doing here, right? This is what this symbol means. We're adding up those values for every group. And then we're dividing by k minus 1. K is the number of groups. So we're dividing by 7, right? Number of groups minus 1. And that gets us this value here in the green box, 1.35. Okay, and you'll notice in the ANOVA test, we actually have that 1.35 appear right here. Okay, and that's the top of our equation. The bottom of our equation, we're actually, within each group, we're taking every data point, subtracting the average value of that group that data point is in, squaring the difference, and we're adding up those square differences for every single data point in every single group. Okay, so right here, so for every single team, right, we have the average for that team. We're subtracting for every single game the goal differential for that game minus that average, and we're squaring the result. Okay, we're doing that for every single game played by every single one of these teams. And so we get all of these differences. All these square differences. I'm going to zoom out to show you all of them. Okay, and we're adding them all up. Okay, for every single game played by every single one of these teams, these square differences, we're adding them all up, and As a result, we get a number, which happens to be 63.75, and we're dividing by n minus k, the total number of games played minus the number of groups. Okay, that's what we're dividing by. And then we get a value 2.65 and so on. And we actually have that right here, 2.65 and so on. And we're dividing one by the other, okay? The top value divided by the bottom value. That's what gives us that 0.509 and so on. And that's what that F value is, that 0.509. Okay, that's where that comes from. And this test is based on a distribution commonly called the F distribution. Okay, this is what it looks like. So you have your curve, and on this axis here, this is this measure of difference, right? So your F value, your test static, is some point along this axis, and the probability of observing that difference, assuming that the groups are the same on average, is the area under the curve to the right of that F value. Okay, so if you have a small F value, right, which means not much of a difference, well then that's a large area to the left of that value, right? It's a very large probability of observing a small difference, assuming that the groups are the same, are the same on average, right? Whereas if you have a larger F value, right, a larger difference, a measure of difference, well then the area to the right of that value under the curve is smaller, right? So if you have a larger difference between your groups, there's a smaller probability of observing a greater difference if on average your groups are the same. Okay, and if you remember that alpha value, okay, that we picked at the very beginning, so 0.05 or 5%, well, this is what that critical value shows. It shows you what would the F value be if the probability of observing a difference like that or greater was 5%. Okay, so this is the F value corresponding to whatever number you put in for alpha during your running the test, right? So you can compare, okay, what is the actual measure of the difference compared to what would it be for a probability of 5%, because we put in 5% for alpha. You can put in whatever number you want, right? So in our case, our difference is less, right? Our F value is less than what it would be for 5%, which means the probability of observing what we observe should be more than 5%, and it is, right? It's 82%. So that is the ANOVA test. Okay, that's how you do it in Excel. That's what these numbers mean. And what we see as a result is there's no statistically significant difference. Looks like there's no statistically significant difference with regards to how these 8 teams performed in the tournament so far. Okay, assuming that on average they would perform the same if the tournament was repeated again and again and again. Okay, assuming that's the case, the probability of observing the differences that we're observing is at least 81.8%, right? And if you count goal differential for Croatia and Morocco differently, right, instead of 0 up by 1 or the actual goal differential for shootouts, well then that percentage can grow even higher, up to over 94%. So looks like the teams have been performing about equally, which means we should have a good rest of the tournament. So I hope you enjoyed that, and I'll see you next time.